So, boys and girls, today we will discuss about different demodulation technique. We have learned a lot about modulation techniques, and if you see that I have skipped the demodulation schemes for every method because I wanted to get a general idea about the demodulation scheme. While going for demodulation scheme, you want to keep in mind the modulation scheme or how it has been generated if you want to understand deeply. Let's understand that a DSB SSB signal is modulated. What it happens when a message signal is modulated by cos omega ct and passed through a band pass filter, we get mt into cos omega ct. Okay, and m2 into cos omega ct looks like that. Okay, that means we are getting two spectrum, one at plus omega c and another at minus omega c. Now see intellectually or simply, if you want, so what was your message signal? Message signal was like here. You have multiplied this signal with cos omega ct. That means you have multiplied by e to the power j omega ct. It is giving this one. And you have also multiplied this signal by e to the power minus j omega ct. It is giving m omega plus omega ct. If you consider cos omega ct by half of e to the power j omega ct plus e to the power minus j omega ct using Euler's theorem. Now, if you understand this, that a message signal was here, you have shifted it to this part and at minus omega c by cos omega ct multiplication. Similarly, can we not shift this signal to here and to 2 omega c if we multiply it 1 second by cos omega ct? Obviously we can. If you multiply this spectrum by e to the power j omega ct plus e to the power minus j omega ct, that means half of cos omega ct, this will shift to another two places. One will be centered at 2 omega c and another will be centered at m omega omega equal to 0. Similarly, if you multiply this or shift this and multiply this by cos omega ct, what will happen? This part will go to minus 2 omega c and this part will go to 0. So what we get if we use the demodulation scheme in that way, that I have the I have the modulated signal mt cos omega ct, and if you multiply it 1 second by cos omega ct, what will be s dash t? S dash t will compose of message signal plus message spectrum shifted as plus 2 omega ct and message signal shifted at minus 2 omega ct. But to get back the message signal, what we need? We need this first term only. Therefore, what we should use? We should use a low pass filter to get this part only. Okay, in that way we can demodulate. And if you carefully consider or think what is the difference between DSB SSB modulation and demodulation, is very simple. Both uses a multiplier and both is multiplied by cos omega ct. A carrier signal is generated, and simply here a low pass filter is used for demodulation and a band pass filter is used for the modulation scheme. So this is all about DSB SSB demodulation. And one important point I missed, that is, here you see we have, for the purpose of demodulation, we have used cos omega ct. That means a carrier signal which has the same frequency and phase as that of the carrier signal that was used to generate the modulated signal. Therefore, the phase and frequency of this signal used for demodulation and also for modulation are in same phase and frequency. Therefore, this is called coherent detection or synchronous detection. The student can also consider a little bit change, that is, if you demodulate it cos omega ct plus phi, some additional phase, you will get that there also you need a low pass filter to get back the message signal. There will be some minor mathematical expressional change that you can easily calculate. Now we will discuss about demodulation of SSB signal. Okay, in the same way as used in the DSB SSB signal, here also you can demodulate it by using a carrier signal, cosinusoidal signal having the same phase and frequency with that of carrier signal used for modulation scheme. At first write the expression of the modulated signal mt cos omega ct minus plus mht sin omega ct. We are multiplying that signal by cos omega ct and we are getting this final expression h dash omega. And student can easily understand, if you use a low pass filter, you can easily get back the m omega, that is message signal. There is another way we will discuss a little bit later, that is envelope detection method to get back SSB signal or SSB with carrier. Okay, okay, that's all.